Right. A car moving with constant speed of 90 km per hour, when suddenly the driver sees a cat 50 meters straight ahead of the car. The driver's reaction time is 0.4 seconds and the maximum deceleration of the car is 11 meters per second square. Calculate the total distance traveled by the car from the moment the driver sees the cat until it stops. And then what will happen to the cat? Okay, first of all, we need to analyze the situation here. We can draw out. We should always, when we see the questions, we draw out the situation, put into a drawing, so we can visualize what actually happened. Okay, so first of all, I draw out. Okay, so there is a car and there is a cat. Okay, there is a car and there is a cat. There's two things here. So I should draw this car and the cat. Okay, they are traveling on the road. Okay, okay, so I can draw a road here. There's a road here. Okay, and then there is a car. Okay, there is a car. Maybe I put just black color is enough. Okay, I should put yeah, sorry. Okay, now I draw a car here. Sorry, draw a car. There is a car here. All right, and there is okay, so I continue. This is the car, right? He sees a cat. He sees a cat over here. He sees a cat. Okay, and then this car is traveling at this speed, 90 km per hour. 90 km per hour. So this is the initial speed, 90 km per hour. Okay, but when suddenly the driver sees the cat 50 meters ahead of the car, so between the car and the cat, okay, between the car, I just put this as A, this one as B. Easier, yeah, to identify. This is the car, this is the cat. And how far is it, the cat? 50 meter. 50 meters, so I draw 50 meter. Okay, it is 50 meter ahead between these two. So yeah, this one. Okay, so this is the cat. 50 meters away. So the driver reaction time is 0.4 seconds. Reaction time and the maximum deceleration of the car is 11 meters per second square. So that means this driver, it doesn't immediately brake. It takes 0.4 seconds after, then only it start to brake. So what I can say is this car is still travel at the same speed, 90 km per hour. After 0.4 seconds, then only it start to decelerate, start to brake. So I can say it travels another until here, okay, then only it start to brake. So from here go to here, still maintain the same speed, which is this one. Okay, it still maintain the same speed. Still maintain the same speed up to this point. Then only it start to decelerate. Sorry. Okay, then only it start to decelerate. So over here it start to decelerate. Over here it start to decelerate, which is okay, because we know that this car decelerate. This decelerate. So the initial speed is going to the right. Remember the rule. Remember the rule. We always use the same rule. Going to the right positive, going to the left negative, going up positive, going down negative. So for displacement, velocity, acceleration, the positive negative sign shows the direction. So to the right is positive, to the left is negative. So right now what we can see is this car, the initial speed is to the right. Okay, so this velocity is positive. Okay, this I should draw. This initial velocity is positive because going to the right. Okay, it is going to the right, positive. However, this car decelerate. Decelerate, that means the acceleration need to be in opposite direction to the velocity. We learned before already. When the velocity and acceleration same direction. Okay, when maybe I can write just velocity. When the velocity and the acceleration same direction, the object accelerate. But when the velocity and acceleration opposite direction, decelerate. Isn't it? We learned before already. Okay, so we don't say that because acceleration positive then accelerate. No, sometimes acceleration negative can also accelerate. You must always compare the acceleration with velocity. Yeah, we don't say that acceleration negative must be decelerate. No. Okay, we need to compare with velocity. If velocity and acceleration both positive or both negative, both same direction, the object accelerate. But if the velocity and acceleration one positive, one negative, opposite direction, then the object will decelerate. In this case, we see the velocity is to the right, is positive, and we know that the car decelerate. Okay, as you can see from here, the car decelerate. So the acceleration and velocity must be opposite direction. So the object decelerate means the velocity is positive. When the velocity is positive, A must be negative. That's why we put this A is negative. We must put A negative. We don't say A negative. We don't say A negative is decelerate. No. We put A negative because A acceleration must be opposite direction to the velocity. Then only the car will decelerate. Okay? Must be opposite direction. Then the car will decelerate. So this A must be negative. You must put A negative. Okay, so A negative, then maybe I should just change this thing into blue. Okay, and then this one is red. Okay, so now what is the deceleration? Deceleration is 11. Okay, so we must put negative 11 meter per second square. Okay, so it decelerate. So before it even starts over here. Okay, what about here? What about this section? Is there any braking happen? Is there any deceleration happen? These ones, how long? It takes 0.4 seconds. That means it starts over here 0 second, and then after 0.4 second, then it only start to brakes. Okay, decelerate. So between the 0 and 0.4 second, is there any braking happen? Is there any deceleration happen? No. So the velocity still remain constant. After the reaction time, only the driver realized need to brake the car. Okay, decelerate. So between 0 to 0.4, there's nothing happen. The velocity is still constant. So over here the acceleration, over here the acceleration is 0. Because no braking. Okay, this one still within the reaction time. This one after the reaction time, then it start to brake. Okay, and then okay, so we can see there are two parts here. Okay, let's talk about here. After braking, of course, finally the car will stop. So we don't know whether the car will stop in front of the cat or behind the cat. Maybe the car just enough time to stop in front of the car, but maybe the car not managed to stop the car in front of the cat and bang the cat. How pity, yeah? Bang the cat, and then it is dead, yeah? Maybe I draw a cat, but it is dead. Okay, this is the cat. So we don't know where the car will stop. So is it stop in front of the cat or is it stop behind the cat? That means if stop behind the cat means it will bang the cat. Okay, so when it stops, that means the velocity is already become 0. Velocity of the car is 0. So there's two possibilities. Is it in front of the cat or behind the cat? Okay, so we need to investigate. Actually, we need to investigate the distance between the car and the cat. So to know about that, we need to find the displacement. Okay, so let's talk about the displacement. Okay, so we have two sections to find. Yeah, we need to know where it stops the cat. Where it stops. Is it in front of it? Maybe we assume maybe in front. Yeah, we always think positive. Okay, so we have two sections. We have S1 and S2. So we need to find S1 and S2. Okay. So what the conclusion we can make is if S1 plus S2 is less than 50 meter, because 50 meter is the original distance between the car and the cat. Yeah, between the car and the cat. If this S1 plus S2 less than 50, the cat is safe. But if S1 plus S2 is more than 50, my God, okay, means it banged the cat. The cat died, right? The cat is dead. All right, so let's find out S1 plus S2. So do one by one. First we find S1, then we find S2, then we total them up. Okay, we total them up. So S1, let's talk about S1. So let's talk about S1. Okay, so how to find S1? But first of all, we need to convert the velocity into meter per second because it is not in SI unit. Okay, so let's do the first part. Let's find out the S1. Okay, let's find out S1. First of all, we need the velocity in SI unit. 90 km per hour. Okay, 90 km per hour. So how to find? What is it in meter per second? Okay, 90 km per hour. So it's very easy. 90, and then the kilo just become the value. Kilo is exponent 3. Right? Kilo is exponent 3 meter. And then 1 hour. This is actually 1 hour is actually 3,600 seconds because it is 60 minutes times 60 seconds. 60 minutes times 60 seconds, isn't it? 1 hour is 60 times 60 seconds. 3,060 seconds. So we can say the per 1 hour we change to second. It is 3,600 seconds. Because 1 hour is 3,600 seconds. So let's calculate what's the answer. Yeah, in meter per second. Okay, so I got the answer. It is 25 meter per second. That's a velocity, 25 meter per second. Okay, 25 meter per second. Okay, so for S1, before he realized, okay, it's still the reaction time still not over. Okay, that is S1. So the acceleration is 0. Okay, no braking yet. Okay, so how far is S1? The velocity is 90. Okay, the time taken is 0.4 seconds. So let's find out S1. So we have to find the S1, we need to find the S1. Okay, the velocity is okay, we already have the velocity. Initial velocity is this. Also the final velocity is still 25. Okay, the time taken is 0.4 seconds. Okay, the person still not conscious yet. Yeah, still thinking want to stop the car or don't want to stop the car. Yeah, still making decision within the reaction time. So 0.4 second, and then acceleration is 0. Yeah, still not braking yet. So what formula do you think to find S? Very simple. S equal to ut plus half at square. But because acceleration is 0, so this half at square is 0. Just substitute a with 0, then the half at square will gone. So the formula becomes the simple S equal to ut. So what's the velocity is 25. Velocity is 25, and then the time is 0.4 second. So what's the answer? 25 times 0.4, it is 10 meter. It's 10 meter. Okay, so we got, this is S1. This is S1. So S1, okay, S1 is 10 meter. So just put there, S1 is 10 meter. Okay, now S2, let's find out S2. Okay, let's find out S2. So I just do it over here. S2, we want to find S2. Okay, S2, initial velocity is still 90 km per hour. Just now we already convert. The velocity is 90 km per hour. We already convert to meter per second, which is 25 meter per second. All right, 25 meter per second. Now, this is already after the reaction time. After the reaction time, the person realized need to stop the car, need to brake the car. So start to decelerate the car. So decelerate, remember, because the velocity is positive, so the acceleration need to be negative. The acceleration and velocity need to be opposite direction so that the car decelerate. So this acceleration we need to put negative, so that it is opposite direction to the velocity, so the car will decelerate. Okay, 11 negative. You must put the negative sign. If you don't put a negative sign, then you are wrong. Okay, so now so these two, because velocity, the velocity is velocity and acceleration. Because the velocity and acceleration, one positive, one negative, opposite direction. Yeah, because the opposite direction, the car decelerate. The car decelerate. Okay, so we already got the. We need one more value. We need one more value so that we can find the S2. So we know that finally the car stopped. We don't know it stopped in front or stopped behind the cab. So we know, but we know the final velocity needs to be 0. So we get another information here. The final velocity is 0. So let's find out S2. So what formula to connect these four? VUAS, VUAS formula. Still remember VUAS formula? It is, the formula should be V square equal to U square plus 2AS. So the final velocity is 0. Initial velocity is 25 in SI unit. You must convert to SI unit. And then 2A. A is remember your negative sign. If you don't put a negative, then you are wrong. Negative 11. Okay, the deceleration is 11, isn't it? 11, that's correct. Okay, you don't put 11. You must put negative 11. Yeah, negative 11. So then, and then S. So what is the answer for this one? So let's find out. This is S2. This is S2, right? Hold on a second. Okay, let's find out the answer. Okay, so I calculated the answer is S2 is 28.409 meter. Okay, so 28.409 meter. Okay, so let's see. So we need to total up S1 and S2. So the total displacement is equal to S1 plus S2, which is equal to 10 plus 28.409. which is equal to 38.409. It is less than 50 meter. What it means is I got the S2 here. The S2 here is 28. This is 28.409 meter. So that means the total of the displacement, the total S here, this is the, the total, this is the total S I got. Okay, the total S I got, this one, yeah. I just copy here. Here. See? So the total displacement, see this one? The total displacement S1 plus S2 is 38.409. That means before the reaction time, before it conscious, until it stops the car, the total displacement is only 38.409, which is less than 50 meter, because from the 0 second up the car to the cat is 50 meter. It is 50 meter, but the displacement of the car for S1 plus S2 is only 38.409. So it's less than 50 meter. So what will happen to the car? And I mean, what happens to the cat? The cat is safe. The cat is safe or alive. Okay, the cat is safe or alive. What's the total distance traveled by the car from the moment the driver sees the cat until it stops? So the total displacement is 38.409 meter. That's the answer. So is this correct? Yes, the total displacement is 38.4. My answer is 38.409 or 38.41 meter. So it's correct. The cat is safe. Okay. So that's all for these questions.